Okay, hello everyone. Today I'm going to talk about the virtualization on the platforms that do not support virtualization and the CROSSCON hypervisor that makes it possible. Who am I? My name is Daniel and I'm the FreeMDevs Zarhus team leader. I'm a bit a bookworm, a cycling nerd, a Linux kernel, and embedded programming enthusiast. I'm going to talk about general information that is needed for you to port and launch your application on top of the CROSSCON hypervisor. We will go through the CROSSCON project introduction, then we will discuss the CROSSCON hypervisor and its features. After this, we will cover some of the demos and its implementation details. What is CROSSCON project? The CROSSCON project focuses on security for IoT devices, providing components that increase the security of the IoT devices, especially the CROSSCON hypervisor we'll be talking about today, and for example, multi-factor authentication. The CROSSCON project provides as well real-world use cases that demonstrate the improvements delivered by the components to the real world. We have already had one presentation and blog post cover launching CROSSCON hypervisor on RPI platforms. If you are interested in the security, virtualization, and Linux kernel, make sure to check our blog post. You can find the CROSSCON project on its website under GitHub organization and LinkedIn page. So what is this CROSSCON hypervisor? Actually, it is a static partitioning hypervisor. That means you have all control in platform resource assignments, including the CPU cores assignments, the interrupts assignment, and the memory and device assignment. CROSSCON hypervisor, as I said, is a static partitioning hypervisor, but how will you run a static partitioning hypervisor with multiple virtual machines on platforms that have only one course? You need a scheduler. So at least one component will be dynamically assigned, and CROSSCON have this component implemented. One of the main features of CROSSCON hypervisor is to provide trusted execution environments. The CROSSCON hypervisor emulates the ARM Trust Zone technology and SGX enclaves to provide this trusted execution environment. And you have really a lot of freedom in customization here. You can define several trusted execution environments. You can assign several trusted execution environments, virtual machines to one general purpose virtual machine like Linux, as I pointed out here. The CROSSCON hypervisor have support for several architectures and platforms. Mostly it is ARM and RISC-V. You can launch CROSSCON hypervisor, for example, on Raspberry Pi 4 platform or on some Cortex-M microprocessors. You can find the CROSSCON hypervisor under this link on GitHub. I'm going to present the workflow of integration of an example application on top of the CROSSCON hypervisor. And this application, this demo I'm going to present was used by us during development in CROSSCON project. This this demo was used for multi-factor authentication between the devices equipped with microprocessors and more powerful devices with more powerful processors, for example, Raspberry Pis. And the goal of this demo was to separate some environment, to separate secrets into different VMs. The goal of the demo we developed, but the goals of this demo is to demonstrate a minimal environment with two virtual machines. One virtual machine is running a simple application like Hello World or something, just to make sure it is present and we can test the configuration with two virtual machines. And the second virtual machine is where the authentication will happen in future. For now, it is only for device, memory allocation, and all other allocation stuff demonstration. This demo have some dependencies, of course, some hardware, the Wi-Fi models that will be used during authentication, the Zephyr RTOS, the HCP client demo, and some, of course, knowledge about Zephyr RTOS. What things you should consider when launching something on top of CROSSCON Hypervisor? This is a static partitioning hypervisor, so you need to provide the configuration during before the building process starts. And here are the three main things you should provide to the configuration before the building process. The precompiled application entry address and flow addresses. You should assign memory where the code and the execution of the virtual machine will happen. And you should assign all the memory mapped peripherals, interrupts, and all other things that the virtual machine and your application will need during running. And we will start from the first point. For the Zephyr, you just need to compile the binary and extract the start address and provide the start address as this entry address to the CROSSCON Hypervisor configuration file. The configuration file is rather simple. It's just some structures in C language. Here you can see the entry address just decreased by 1 byte. Then the second point, the virtual machine memory assignment. You have to assign two kind of memories here. The memory where your application will be stored before running. This is, for example, code, statically defined variables, etc. And the memory that will be used for during the execution of your application. You can find those in the Zephyr RTOS device trees. Then comes the hardest point of all those three. You need to go through your device tree and look for all of the devices your application needs and define them in the not defined but assign them to the virtual machine your application will be running in the CROSSCON Hypervisor configuration file. Here you can see the assignment of random number generator. As you can see, the physical addresses and the virtual address is the same, so there is no need to change anything in the Zephyr RTOS device tree and the size of the region of the memory. Then there is another device we had to assign during development. This is wards. And they will show us the interrupts assignment. These are the modifications from Zephyr RTOS device trees, so to outline the words we were using and what we were using it for console, and one of the words for communication with the Wi-Fi module. Here is the assignment inside the CROSSCON Hypervisor device tree. As you can see, we have here two devices, two UARTs. As I said, one is for console, for logs, and the other is for Wi-Fi module. The same here. The physical address and virtual addresses are the same. Interrupts, you will have to go the hard way and check the interrupts in the MCU vendor documentation. And I wanted to point out one important thing here. This is not shown on the presentation, but is described in the blog post I will mention later. You will have a limited number of the structures in the hypervisor configuration file because of the CROSSCON hypervisor architecture on Cortex-M platforms. Just keep it in mind. And if you want to check the reason, check the blog post I will mention later. And this is an empty slide. Yeah, curious, interesting. I supposed to show here the final results, but somehow it is empty, unfortunately. So we are heading directly to the questions and answers. Any questions?
The previous slide wasn't empty for me. I see
So
two images and two points. Yes.
Okay.
2 points.
Then it was empty for me somehow on present.
This is because you have enabled drawing. I guess you have to disable drawing, then you could be able to switch just
okay, I do see it now too. Magic. Okay, and here you actually see the reason. We have the limited number of the device's structures in the CROSSCON hypervisor configuration file. And the blog post. It is not published yet, but monitor our blog freemdeb.com to be up to date, and it will appear probably in the next few weeks. Here's the final result of the running demo. Unfortunately, it is a bit small. Sorry for those who are watching it from some phone, but I guess those from the laptops to see it. We have booted the Zephyr RTOS demo. It works fine. It gets the IP address. We have booted the CROSSCON hypervisor as well with proper addresses assignment here and interrupts, and it is running. Yes, and that's it for me. Questions and answers, if somebody have any.
Yeah, so maybe a little bit about potential use cases for that.
Potential use cases. First of all, the thing I really like is bringing virtualization on the platform without virtualization. So you can, virtualization means separation and means you can protect something from the outer world. For example, your secrets, as we will be doing in the multi-factor authentication, when we will be storing our secrets in the separate virtual machine. This will reduce the attack surface on those small devices that are in the 21st century is everywhere, in every corner.
Okay, so bringing the virtualization to some microcontrollers without virtualization. Okay, of course that not without penalty, definitely some overhead. But there was this seemingly use case about connecting some devices like a Wi-Fi device. So how connecting some devices and like isolating some devices for given virtual machine? Do you see any potential for that?
I'm not sure I have understood the example.
So we potentially can blog post showing some redirection of or assignment of the Wi-Fi to given VM, correct? Or am I missing something?
Correct.
Mm-hmm. So what value this brings?
Potential separation, for example, the multi-factor authentication. There are different technologies for multi-factor authentication, and some of them use some hardware to produce secrets for second factor, and you can separate this hardware. So the attacker, if he will have access to the site, still can do some attacks here on this VM, but it will not be able to steal the logic or steal the actual secrets from this site, for example.
Okay, makes sense. So even if the network stack or IP stack will be vulnerable, then we still have protection. Our secrets are protected. Our authentication mechanics is protected. Okay, that's some reasonable value. Okay, thank you very much for that. And I guess we're getting through to Macie's presentation about the Shadow Toolsuit, our primer ZARHUS OS distro. So Maciej, stage is yours.